Boom.
That's one point. That's what I want. So,
all right. So, hello and welcome back to Differential Equations, Chapter 5, somewhere in 5.2. We are picking up where we left over years ago, I guess. What seems to be years ago. I talked about differential operator. Differential operator is applied to a function and changes the function. So technically it's just renaming what you know from before, calling the d or dx capital D, and then second derivative d squared. You can do the third derivative as d cubed and so on. Differential operator is a linear operator. So a lot of linearity properties, well, all of the linearity properties are there. So we can do some really cool, interesting things with this. So what I did is I introduced the notation. So we have function x of t, which is unknown. So we have the second derivative plus 3x prime minus 4x equal to 0. We know how to solve this, right, using the constant coefficients and so on. But I wanted to do the transformation into the polynomial differential operator. And I wrote out all of these derivatives. And as you can see, we now have the d's instead of the d dt. And what we do on the bottom is we factor out x, and you're left with d squared plus 3d minus 4. And that is called the polynomial differential operator. So we can use that one for some stuff coming up later. Now, this is presented in your textbook, but it's a little bit harder to understand because of the way they put that together. So I want to take a look at a system of differential equations, because that's what the chapter 5 is about, system of differential equations and the ways to solve them. And I want to see if we can first solve the system of differential equations using the elimination method, the same way you would use the elimination method to solve any of your two unknowns from before. And I will talk about the importance and power of this stuff later. So, find the general solution of the system. Come on, pen. There we go. D minus 4x plus 3y equal to 0, and negative 6x plus d plus 7y equals 0. Now you're looking at this and probably going, what the hell is that? Well, this is going to be what we know as the coupled system of differential equations. What I'm going to do now is not a part of solution. It is the conversion, so we actually know the form of the equation in its vanilla state, I guess? I don't know. So what you can do is distribute this x, and you will have x prime, y, negative 6x, come on. So you will have x prime minus 4x plus 3y equal to 0, and you will have negative 6x plus y prime plus 7y equal to 0. So I'm just converting it back to see what it looks like. I'm not going to, and then I'm going to go back to solving it. So now I have x prime is equal to 4x minus 3y when I shift everything to the right, and the y prime is equal to 6x minus 7y. So you see it's a system, right? It's a system, and it will be your job when you get a system like this, which is what I'm having here in blue, to convert it to the form in black and then solve it. Now you might say, well, I already know how to solve the one on the bottom. Do I really need to go to the one up there? And I would say yes, because when you have more than two equations, the old methods don't work, right? So this is going to be setting the tone for the universal, right? Yeah, let's say you have 22 equations, right, to couple. Like some of the, I think current weather model has 22 coupled equations with a constant input of the temperature and pressure and everything else, right, as conditions. And that grinds the, 27 equations. I don't know. It's just, it's mess. So what am I going to do up there? Well, I'm just going to solve the problem using the regular means that we know of solving for x and for y. Because remember, our goal for differential equation is to figure out what is x of t and what is y of t. So if I am able to figure that out from the thing up there using just a regular algebra, we're not going to touch any derivatives or integrals or anything like that, we should be good to go. So how do I do that? Well, you can place this in the matrix of coefficients, right? Multiplied by xy. We will talk about matrices much more later. So there we go. So if I have a, b, c, d times xy equal to 0, 0 is exactly what we have in this case. So now you take xy and you multiply onto ab, so you get ax plus by equals to 0, and cx plus dy equal to 0. So now, no, they will ruin everything.
You can scale them with math.
Actually, yeah. Bring forth the young ones. All right. So now what I have is d minus 4 as the entry in the matrix, and then negative 6, and then 3, and then d plus 7. So these are the entries in the matrix multiplied by xy equal to 0, 0. So now what we do over here is we can get the operational determinant, which is, we know how to calculate the determinant, multiply diagonal, subtract the product of the other diagonal. So we have d minus 4 times d plus 7 minus negative 6 times 3. I write out everything. And now you FOIL. So that's going to be d squared plus 3d minus 28 plus 18, and that's equal to 0. So d squared plus 3d minus 10 equal to 0. So what this does is it gives us the differential polynomial, right, which we can apply on x and y. So now you apply this operational differential operator onto an x, and what you get is x double prime plus 3x prime minus 10x equal to 0. And you know how to solve this using your good old R, right, characteristic equation. So you have r squared, come on, r squared plus 3r minus 10 equal to 0. Factor it to get something. R minus plus 5 and then r minus 2 equal to 0, which gives you the solution x of t is equal to c1 e to the 5t plus c2 e to the negative 2t. It's plus 3r. Oh, over here, you mean? Yeah, obviously, yes. It's clear, look, it says negative 5. All right, so now that we know, hello? Oh. Now we know x, y has the same form, but it's c3 e to the minus 5t plus c4 e to the 2t. And we have a second order system with 4 coordinates, 4 constants, and that's not good. So what we need to do is to figure out the dependency of C3 and C4 on C1 and C2. And we can do that by plugging in solutions into differential equation and working out the coefficients. You had the hand up.
Is that always true that the yt is going to have the same form as your x system?
Yes. So now we are going to plug this solution that we have into our differential equation. Pick any of the blue ones, it's fine. X prime is equal to 4x minus 3y. So green, huh? Work out C3 and C4 in respect to C1 and C2. That's what we're doing now. So I'm going to use x prime is equal to, it doesn't really matter which equation you use, you just use any equation, 4x minus 3y. 4x minus 3y. So this is one of the equations given to us. And the way I do this is I just plug everything in. And then the relationship between C3s and C2s and C1s, C4s will all work out. So let's take a look. X prime is negative 5 C1 e to the negative 5t plus 2 C2 e to the 2t. So that's the left-hand side. And then 4 times x, so that's 4c1, oh, come on, 4c1 e to the negative 5t plus 4c2 e to the 2t, and then minus 3c3 e negative 5t minus 3c4 e to the 2t. So what I did is I replaced the solutions x and the y, right, in x and a y, multiplying them by 4 and negative 3, and I also took the derivative of x and plugged it for the x prime. So this is just the substitution. I just plugged everything in, and now we have a pile of stuff for e to the 2t and a pile of stuff for e to the, so we can separate those into two separate worlds. So the coefficients, so maybe here in blue, coefficients of e to the negative 5t all have to work together. So that's going to be the blue equation. So I have negative 5 c1 equals 4c1 minus 3c3. So when I move 3c3 to the left, becomes positive. I move this one here, it becomes 9c1. So c3 is 3c1. Ryan, you okay?
Yeah.
All right.
I just had a mild heart attack because I didn't get 100 on test. 6 1.
And then we have a 2c2 is equal to 4c2 minus 3c2. No, c4. No coffee. And then we have 3c4 is equal to, so 3c4 is equal to 2c2, from where c4 in terms of c2 is 2/3. C2. There we go. So we worked out the relationships between C1 and C3 and C2 and C4. So that eliminates two of the constants, and we have our x of t to be C1 e to the negative 5t plus C2 e to the 2t, and y of t to be, now C3 is given as 3C1, so 3C1 e to the negative 5t plus 2/3 C2 e to the 2t. Done. So we were able to use this really clever method. We haven't done any integration, haven't done any differentiation, anything like that. We just simply went through the system and converted the system, and that's it. So let's do one more example from homework, and 5.2 is over, and then we're going to take a look into matrices.
I know we didn't cover ionized, but this looks stupidly similar.
Yes, it builds up into it. So x prime is equal to 3x minus y, and no, wait, minus 3x minus 4y, much better.
Which problem number is this?
Number 5. And then y prime is equal to 2x plus y. How about I give you about 2 minutes to convert this into the differential operator form. Factor everything, get the matrix, then get the operational determinant, solve the problem. 1 minute. No pressure. Yes.
How do you get from, how do you get that e plus 3x plus 4y?
Because the derivative of x prime is written as this, right?
Right.
And then you have plus 3x, and then you rewrite this d dx in a different notation, and then when you factor out x, you're left with d plus 3, and then you put x after it instead of in front. It make sense? So just change the notation. Did you all guys get? I'm sorry?
That's what you're doing, just changing notation.
Mm-hmm. Let me just see if I copy this problem right. Yeah, I did copy this problem. Did you all get the same d squared plus 2d plus 5? All right. So now we have to factor this, right? And what do we get? So we get complex. Good. So we have now, well, the conversion happened already, right? So conversion happened, then the matrix happened, then the determinant happened, and now we are at the point where we have x double prime plus 2x prime plus 5x equals to 0, and you have the same thing for y. So we're just going to keep x's there, which gives us r squared plus 2r plus 5 equal to 0, which gives us that r 1, 2, right, is equal to, and you gave me the complex values. What was that? 1 plus 2i?
Negative 1 plus or minus 2i.
Plus minus 2i. Thank you. So now we know what's happening with the complex values. X of t is equal to c1 e to the negative t cosine 2t plus c2 e to the negative t sine 2t. And y is going to be c3 e to the negative t cosine 2t plus c4 e negative t sine 2t. And now all we need to do is to figure out, there we go. All we need to do is to figure out C3 and C4 dependency, right, on C1 and C2, which is going to be far worse than before because we have product rules all over the place. But such is life. We signed up for the course, right? So y prime is equal to 2x plus y. So now to find y prime, we have the derivative of y as C3 e to the minus 3 and then minus sine, and there's a 2 and then 2t, so that's plus the derivative of this, so it's a minus C3e to negative t cosine 2t, so that's the derivative with the product rule, equal to, and now 2 times x, which is the whole thing on top, so 2 times x, so 2c1 e to the negative t cosine 2t plus 2c2 e negative t sine 2t plus c3 e negative t cosine 2t plus c4 e negative t sine 2t. There we go. Now, what happened? Is it okay? Oh, what's the question? Yes. The derivative of the first times the copy first times the derivative of the second, but you have a negative 2 because of the, and then copy, you copy the second derivative of the first is a negative t, right? Chain rule, so changes the plus from product rule into a minus.
But then the plus C4 will be negative 2 sine 2t.
Oh, no. I knew I left space for something. Plus the whole thing derivative here, so copy the first. Thank you. So copy the first times the derivative of the second, so that's going to be 2c4 e negative t cosine 2t plus minus c4 e to the negative t sine 2t. There we go. Should I say much better? No. Okay. Now, all of the terms that are sine. So this is for the sine. This is for the sine. This is for the sine. And this is for the sine. So I have negative 2c3 minus c4 equal to 2c2 plus c4. Great. And then I have purple, cosine, 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 and cosine. So negative c3 plus 2c4 is equal to 2c1 plus c3, right? So we can combine some of these guys and make it a little bit easier. So c4, that's a 2c4. So I have negative 2c3 is equal to 2c2 plus 2c4. I can divide by 2 to make numbers smaller. And I get the first equation as c3 is equal to negative c3, c2 plus c4. And then on the second one over here, I have negative c3, so 2c4 will be 2c1 plus 2c3, divide by 2, and I get that the c4 is equal to 2c1 plus 2c3. What happened?
You didn't divide by 3.
Oh, C1 plus C3, yes. All right, so now I'm supposed to write C4 in terms of C1 and C3 and C4 in terms of, right, these guys. So how are we going to achieve that? And matrix would be overkill for this. So what you do is you move negative C3 plus C4 is equal to C2, and negative C3 plus C4, no wait, this is minus over here, equals to C1. So I moved C3s and C4s, everything on the left, and left C1 and C2, which is what I need everything in respect to. And now look, you just simply subtract these equations and add these equations to get the relationships between these. So if I add equations, I get negative 2C3 is equal to C1 plus C2. So from there, C3 is equal to C1 plus C2 over negative 2. And if I subtract equations, then C3's die. So I have, if I go 2 minus 1, right? Bottom minus the top. So these are gone. This becomes 2C4 is equal to C1 minus C2, from where C4 is equal to C1 minus C2 over 2. I got the relationships. And now we do the, what do we do now? Now we just put the solution together. There we go. X of t is equal to C1 e to the negative t cosine 2t plus C2 e to the negative t sine 2t. That's the first one. And then the y of t, would be, so C3 is replaced with this one. So C1 plus C2 over negative 2 e to the negative t cosine 2t plus C1 minus C2 over 2 e to the negative t sine 2t. There you go. Next time someone tells you, what do you know? Work this out on a napkin. Do what?
I can do a project on Twitter.
Is this good enough, or we're looking for another example? It gets to be crazier. I can sense the pain. So I guess move on. 2 examples enough? All right, fine. So let's stop the stream here and redo it.